Coming to another video. In this video, we are going to discuss about sensors. We might have a basic idea about the sensors. The sensors are using anywhere, everywhere nowadays, in the mobiles, hospitals, shopping malls. Coming to sensor, it is a device which senses anything, depends on the concept, and it gives the proper signal to the display. Senses something or whatever we are going to sense, we need the sense which senses that one and it gives to display. It's called sensors. So the sensors are of three types: optical sensors, thermal sensors, and electrochemical sensors. These are the major sensors. Nearly out of all the sensors, mostly we are using this electrochemical sensors when compared with optical sensors, thermal sensors. Coming to electrochemical sensors, coming to the basic construction of electrochemical sensors, it has three electrodes. One is working electrode, or it also acts as anode, and the other is counter electrode. This one also acts as cathode, and the other one is another counter electrode. These three electrodes are placed in a plastic casing, and this space is filled with electrolyte gel. These three electrodes are connected to the amplifier, and this is directly connected to the display. If we can detect any change in the current or conductance or potential, we can that the amplifier amplifies the difference and it will be displayed in the display. Coming to the classification of electrochemical sensors, again these are of three types. First one, coming to electrochemical sensors. What are electrochemical sensors? The sensors, it is a device which senses the electrochemical change. Any electrochemical change, it detects the electrochemical change and it is shown in the display. And this electrochemical sensor are of three types. First one, amperometric sensors. Next one, potentiometric sensors. And another one, conductometric sensors. The electrochemical sensor is a device which senses the change in any electrochemical signal and it detects the change and is displayed. Again, these electrochemical sensors are of three types. First one is amperometric sensors, next potentiometric sensors, and the other one is conductometric sensors. Coming to types of sensors. These amperometric sensors sense the change in flow of electrons. That means it can detect the change in current. Next, coming to potentiometric sensors, it detects the change in potential. Next, conductometric sensors, it detects the change in conductance. Coming to the potentiometric sensors and amperometric sensors, we will discuss these two types of sensors. First, coming to the sensors, first one will act as, here we have two electrodes. One will act as working electrode and the other will act as reference electrode. These two are connected to the potentiometer, and this potentiometer, we have the display, it will show the difference in the potential. Coming to potentiometric sensors, already we discussed that we have already known that change in, it can sense the change in potential. It senses the change in potential. If a solution is there, if it has any potential change, like if the concentration is varied, then it can sense it and it is displayed in the potentiometer. Coming to the for this we have to take selective electrode, ion selective electrode. if we want to detect the concentration of any ion, we have to take according to that ion. For example, if we are going to detect the concentration of H plus ion, if we are going to detect the H plus ion only, to detect the H plus ion, here we are going to take glass electrode. Like that, we have to take, in the potentiometric sensors, we have to take ion selective electrode based on our necessity. If we are going to detect H plus ion, to detect the H plus ion, glass electrode is taken. The other one will act as reference electrode. If there is a change in potential, it can be measured using potentiometer. Now, coming to the application of potentiometric sensors, we can detect the glucose in blood. Glucose is a neutral molecule present in the blood. We can measure the glucose, amount of glucose in blood. This glucose treated with water and oxygen, and it gives gluconic acid and H2O2. These H2O2 again gives H plus ions and oxygen molecule. Now, if we have taken the test solution, if we taken a blood sample, we are going to calculate the glucose in the blood. That glucose, whenever treated with water and oxygen, it gives gluconic acid and H2O2. This H2O2 again on decomposition, it gives H plus ions and electrons. The change in the H plus ions can be detected by this ion selective electrode, so that there will be a change in the potential with the change in the concentration of H plus ions. This will be displayed in the potentiometer. So if we consider application for potentiometric sensors, we can detect the concentration of glucose in our blood, so that we can say the person who are having more glucose content will be considered as diabetic. So this is one of the application for potentiometric sensors. Now coming to amperometric sensors, we already tell that change, if it measures the change in current. What is current? Flow of electrons is current. If it measures the flow of current in the solution, it is amperometric sensor. Now coming to the application, for amperometric sensors, if we have taken a person urine, we can calculate the concentration of uric acid in the sample. This uric acid, in the presence of urease enzyme, it gives allantoin and hydrogen peroxide. This hydrogen peroxide again gives H plus ions and electrons. This flow of electrons is measured in amperometric sensors. So with the flow of electrons, we are going to measure the concentration of uric acid, this uric acid, so that concentration of uric acid tells the person's healthiness. If the concentration of uric acid, he might be suffering from some infection, like that. So coming to first, electrochemical sensors. Common construction of electrochemical sensors, it have 3 electrodes. One will act as working electrode and the other 2 will act as counter electrodes. Among the working electrode and working electrode also acts as anode, and among the 2 counter electrodes, one will act as cathode. These are connected to amplifier, and there's anything changes will be displayed in the display. Next, sensors are of optical types, different types: optical, thermal, electrochemical, like that. We have the electrochemical sensors. This electrochemical sensor senses the electrochemical change and is displayed. these electrochemical sensors are of three types: amperometric sensors, potentiometric sensors, conductometric sensors. If the sensor changes detects the change in current, those are amperometric sensors. The sensors which detect the change in potential, those are potentiometric sensors. Sensors which detect the change in conductance, those are conductometric sensors. Now potentiometric sensors, which measures the change in potential. For that we have to take ion selective electrode. Here, to detect the H plus ions, I have taken glass electrode. This glass electrode detects the H plus ion. So application, if we have taken blood sample, in that blood sample, if we are going to calculate the concentration of glucose, this glucose gives gluconic acid and H2O2. This H2O2 gives the H plus ions. These H plus ions are sensed by this glass electrode, and there will be change in the potential, so that it is displayed in the potentiometer. Next, coming to amperometric sensors. These sensors detect the change in current. That means it detects the change in flow of electrons. For example, if we take uric acid, urine sample, if we are going to calculate the concentration of uric acid, this uric acid is treated in the presence of urease. It's an enzyme, and it gives allantoin and H2O2. This H2O2 releases electrons. This change in the electron, this flow of electrons can be detected here. So it is amperometric sensor. Thank you.